While there are countless tutorials on visuals, particle systems, and mapping with TouchDesigner, the DMX side is still somewhat underrepresented. That's why I'm going to walk you through my latest project, where I used TouchDesigner to control 40 LED chains. First, I'll show you what the setup is capable of and how it looked at a techno event I did with some friends. Then, I'll break down the costs. After that, I'll guide you through how to recreate the entire setup step by step. This video is aimed at multimedia artists who want to get started with DMX in TouchDesigner and offers a solid starting point for exploring more advanced light installations down the road.
At the first look, we have the laptop attached with a cable to a Advitech PixLite 4 Mark II DMX controller, and out of that the LED strips come out. Additional to that, we can combine it with an audio interface for real-time audio reactivity. The LED stripes have thread attached to the end, where you can attach them, save, and they are waterproof. This makes them ready to use for outdoor events as well. I use them to dynamically light the stage, which I build together with the Unahut and Kiwi Collective in Halle. Assuming that we have the laptop, TouchDesigner, and audio interface already, I am listing you which hardware components are needed. DMX controller, Advitech PixLite 4 Mark II, equals 309 euros. Pixel strips chains, 40 x WS 2811 RGB LED 12mm pixel chain, equals 500 euro. Switch and power supply, AC 100 to 250 volt to DV 5 volt × 5A, equals 20 euros. Crimping tool with wire end for rules caps, equals 26 euros. Cold appliance cable, IEC 13, equals 7 euros, which is in total 862 euros. If working with electricity is new to you, you'll need a friend with electricity skills as well, or pay for an electrician. DMX Knowledge DMX 512 stands for Digital Multiplex 512. It was developed back in the 1980s and is still the standard way to control stage lights, dimmers, fog machines, and other lighting effects. DMX sends 512 control signals, called channels, in one group, called a universe. Each channel controls something small, like the brightness of a light or its color. The data travels through special XLR cables, usually with 5 pins, but in my case, I used 3-pin cables. Devices are connected in a line, one after another. This setup is called a daisy chain, kind of like Christmas lights. One cable goes from the controller to the first light, then from that light to the next, and so on. So, while DMX is great for simple direct setups, things start to get tricky when you need more channels or longer distances, and that's exactly where ArtNet comes in. ArtNet is a more modern protocol made by a company called Artistic License. It sends DMX data over regular Ethernet cables, the same kind used in computer networks. ArtNet can send a lot more data than regular DMX, up to 32,768 channels or more spread across many universes. It works over a network, so you can use normal hardware like routers and network switches. Many lighting consoles, apps, and tools, like TouchDesigner, support ArtNet out of the box. Why it's useful? You get way more control channels, multiple devices can talk to each other, and cabling is easier, especially in bigger venues. But you need to understand a bit about networking, like IP addresses and subnets. And if your network isn't set up well, you might get a bit of lag.
Make a line stop.
Set the X value of point A to minus 0.5. Then set the X value of point B to 0.5. Because every output of our PixLite has a total of 500 LEDs attached, we set the number of points to 500. Connect an add SOP and turn on delete geometry, keep points. After that, connect a transform SOP and set TX and TY to 0.5. Then attach a null SOP. Now that we have our 500 points, we convert them into chop values, make a SOP to chop, and drag the null SOP into it. Now we create a rectangle top. Set the resolution to X equals 500 and Y equals 1. In the Rectangle tab, change the center units to pixels. Turn off anti-alias. This will make the values for the LEDs more precise. Press the middle mouse button and offset the rectangle in the X direction. With that, We test the LEDs later. After the rectangle top, attach a null top. Create a top to chop and put it in line after the stop to chop. Delete the A at alpha and set RGBA units to 0 to 255. This is very important because we are in the RGB color space where colors are calculated with the red, green, and blue channel, where 000 is no light and 255, 255, 255 is white color. After that, attach a shuffle SOP and use method sequence all samples. This should display now just one data line with the length of 1600 samples and maximum values with 255 if you have the rectangle in the frame of your top. Now comes the tricky part. Remember that one DMX universe has 512 channels, i.e. a maximum sample length of 512. But our data line has a length 1500. We need to split that line into several parts where each part is a new DMX universe. Create a second shuffle SOP and select Split N Samples. And now guess after how much samples we should split our data line. That's right, we split after 510 samples, and I explain why. Because every sample step is one channel, we could control 170 RGB LEDs with one universe with a chop that has 510 samples. But for LED 171, there would just be one R channel at step 511 and one G channel at 512, and the values for the blue channel would be missing. Overall, it would mess up the data for every LED pixel after 170. With that being said, this was already the most difficult part logic-wise. We got now for our controller output 1, the data for 10 RGB pixel chains split into 3 DMX universes. If we would just use 10 chains at output 1, we would be fine with setting up the DMX out chop. But we want to use all 40 chains. So we need to copy the DMX data 3 times and merge it together. I show you how. After the shuffle 2, connect a rename chop. For from, write R star, and for to, write universe star. There is no naming convention. You can name it how you want, but I like to keep it clear. Then copy the rename chop, write universe 3-3-5. Copy that rename also, write universe 6-8. And copy that rename chop also. Write universe 9-11. Now we merge the data together, create a merge chop, and after that create a DMX out chop. You can leave the network address as it is. Under local address, type in your local address. LOL. Let me show you how to find your local IP address. The local address is the IP address of your Ethernet/LAN output connection. To find it, you open your Windows terminal, type ipconfig, and press Enter. Under Ethernet adapter Ethernet IPv4 address, you find the local address. Now copy and paste it in the DMX out. But now what? It's still not working. We have to register all universes in the DMX routing table. Click on the magenta arrow of the DMX out. Press the plus to edit the routing table. For every universe, we need to add a row. Knowing what net and subnet does is not important for the level of complexity of our project.
Registering all universes is tedious, so I give it a quick time lapse. All right, now press Save Project, and we are done.
Now that we have our project file set up, we can start connecting the hardware. In order to connect the DMX controller to electricity, we need to cut off the end of the power supply cable. When you cut the end off a cold appliance cable, IEC C13, you'll find 3 internal wires, brown live, blue, neutral, and green, yellow, earth, ground. These are standard for AC mains connections. If you're wiring this cable into a power switching supply that converts 230 volts AC to 5 volts 5 amp DC, you'll connect the brown wire to the L line live input, the blue wire to the N neutral input, and the green-yellow wire to the PE protective earth terminal on the power supply. Always ensure the power is disconnected before wiring, and double-check connections to avoid electric shock or damage. To connect the 5-volt DC output of the switching power supply to the input of the Advatech PixLite 4 Mark II DMX controller, you can use another piece of a cold appliance cable or a second cold appliance cable. Since the controller only requires positive and negative DC power, you only need the brown and blue wires. In this case, repurpose the brown wire for plus 5 volts, positive, and the blue wire for ground, negative. The green-yellow earth wire is not used and should be safely insulated. Make sure to verify polarity before powering the controller, as reversing the wires could damage the device. Now let's connect the Pixel chains to the controller. The chains that I got have 3-pin connectors. I had to cut off the male connector to expose the strands of the 3 wires. RGB Pixel chains have one positive wire for power supply, one data wire that transfers the DMX data, and one negative wire that is the grounding of the electricity circle. After cutting off the male 3-pin connector, you can attach ferrules to the exposed wire ends for a clean and secure connection. Strip about 6 to 8 millimeters of insulation from each wire, twist the strands, and insert them into appropriately sized ferrules. Then crimp them using a proper ferrule crimping tool. This ensures a solid, reliable connection when inserting the wires into screw terminals, preventing loose strands and improving electrical contact. The terminal block of the PixLite output has an additional terminal screw for a clock wire, but we don't need it here. From left to right, we connect the positive wire, leave one screw terminal out, and then connect the data and negative value. This process has to be repeated for every output. We can connect the other chains with their threaded mount. The setup is now ready for use. Let's test it.
With everything in place, you've got a powerful and flexible system for creating stunning LED visuals. Thanks for watching, and feel free to drop questions or comments below if you need help troubleshooting or expanding your setup.